Until now, chemicals have been used and produced without being tested upfront because it has not been required and because it's costly to test chemicals. Traditionally, chemicals have been regulated first when there has been a problem that has been noted, and it's taken a lot of time to gather evidence and be sure that what chemicals is causing the problem and to regulate only that one. But with the new European regulations since 2006, at least there is this mechanism now that you should register whatever substance you produce and use. And for the high volume chemicals also with some data. But it's still the issue that a lot of chemicals are produced and used without so much knowledge about what effects they have on human health and the environment. So the knowledge gap is still huge. It's improving, but it's slow. And the regulation has so far been very much one by one, so one chemical at a time. And now there are proposals to regulate several bisphenol chemicals and not just bisphenol A, because the other ones are similar. And also to regulate a larger family of PFAS chemicals. And there are thousands of them, but only 2 have been regulated so far. So it's going in that direction, but it's taking a lot of time. So there are some plastic types that are generally seen as less problematic, and PET is, for example, one of them. But it's always a case-by-case issue. There may be problems with some PET that are contaminated with something or that has been used for something special. And so I wouldn't be comfortable to say that a specific type of plastic is always safe, because you cannot know that. Today, lots of plastic is used without us knowing if it's safe for human health, but I would also say that a lot of plastic is used in spite of us knowing that there are chemicals there that are hazardous to human health. And traditionally, we know that PVC is an extra problematic plastic because it contains a lot of additives that are known and also classified as hazardous to human health. So plastic is used like in everything in our everyday life. We know a few things are more important. So for example, food packaging and that we get a lot of chemicals in general through what we eat and drink, both from contamination in the environment, but also from the packaging. So one thing I never do is microwave food in plastics, for example, because we know that the heat also releases a lot of stuff. Another source that is very common is the electronics. It's a lot of flame retardants and other things often in that ends up in the dust in our house, and then we breathe it in. So that's also a route of exposure. We know that there are studies connecting like PVC flooring to kids and also cats, indoor cats, being exposed to much chemicals and having high levels of these plastic chemicals in them. So there are different ways in our everyday life, but I think food and drink is something we can relatively easy control, and which is also a huge source of these chemicals. I think it's a scale. All chemicals are sort of in a scale from being benign to very hazardous. And how we treat them should be differently. So for the most hazardous chemicals, it's very difficult to control that those are never getting out where they should not be. So in my opinion, those should only be used in extremely limited and justified cases. But then there is the scale from some problematic properties to almost none. And as the chemical industry loved to say, salt could kill you too. So meaning that even if a chemical has not very many problematic properties, it could be misused somehow and be problematic in specific situations. So we need some kind of control on most chemicals, and they should be used in the right places. But for the most hazardous ones, there are no right places. Actually, it needs to be super controlled and justified. So the cocktail effect is a popular term of acknowledging that we are never exposed to only one chemical at a time, because we get some chemicals from our food, some from water, some from the air we breathe, some from the clothes we wear, and so forth. So we are really exposed to this mix. And what this does to us has been a whole field of science. And we know that some chemicals, they can interfere with each other, so that the effect of two chemicals could be more than the combination of it's not just 1 + 1, but together they do something so that the effect is even worse because we have several. And then we have all these, it can be several hundreds of man-made chemicals in our blood. And it's hard to know what all of that does together in this mix. So that is what is called the cocktail effect. And so oil and plastics are definitely linked. Plastic is mainly made from oil, and it has been proven, like, for example, now during the pandemic, when oil has been used less for fuel, the plastic production has gone up and the oil prices have gone down. So they are tightly interlinked, that oil is used either for fuel or for production of plastics and chemicals. And either way, if it's for fuel or if it's for plastics and chemicals, it's still in the end a CO2 emission that is more than that comes that is added to the planet that was not there originally. So it's raising the CO2 concentrations.